Okay, folks, for example number 4, I've got these two fractions that I need to add together. Now, before I get to these two fractions, I want to go back to a problem we had just a minute ago. You know what? Actually, it was the perimeter one. Okay, let me go back. Ryan, I think you were the one that helped me with this. When we got down here, okay, we had 2 and 3 as the denominator. Now, both of these things are prime, right? I can't break them down any. If they're both prime, if I can't factor the denominator, then the least common denominator is just these two things multiplied together. And that's what Brian did. He did 2 times 3 and gave us 6. Since 2 and 3 are prime, the smallest denominator is just the two of them multiplied together. Now let's think about that as we look at this next example. All right? I need a common denominator between these two things. Can I factor x plus y, Ellie? No. So to make the least common denominator, which is what we did last night, I got to have x plus y, right? What do I need in order to make the other denominator, Jet?
X minus y.
So I need to put an x minus y down here too. Now that's the least common denominator. I can make both of these from the least common denominator. Everybody happy with that? Okay. All right, well let's look at this now. I'm going to take this and just move it to the side. Our new fractions are something over x plus y times x minus y plus x plus y, x minus y. Now remember last night in the later problems they said rewrite the fractions. Well, that's what we have to do here. All right? Libby, what's new? What changed from this denominator to get to this one?
You added x minus y.
I did. So I need to do x times x minus y on the top. Okay? Excellent. Lauren, what's different between this denominator and the next one?
X plus y.
So that means I need to multiply the top times x plus y. Is everybody clear on that? This is just what we did last night. Exactly. Now we have a common denominator. We need to put them together. Okay? Jet, you could simplify right now. I'm not going to. But you could. You want to? Jet wants to. He wants to see what it looks like. Okay. So now I've got, let's see, now I have to rewrite x squared minus xy. That's what this one is. Right? Okay. All over x plus y times x minus y plus xy plus y squared all over x plus y times x minus y. Now, I need to remember, these are quantities, so I keep them in their parentheses so that I make sure that I get the signs right. If this thing is minus, that's going to change all the signs in the second one. Okay? It's not for this one, but x squared minus xy plus xy plus y squared all over x plus y times x minus y. Now, I have to distribute because I got to put them together. And I have to simplify them in order to do that. So now I'm going to drop the parentheses, and that gives me x squared minus xy plus xy, nice, plus y squared, all over x plus y times x minus y. These two things just cancel out. That leaves me with x squared plus y squared over x plus y times x minus y. Max, am I done? No. What do I have to do here? No, I'm going to leave these two things factored. What I want to do is I want to factor the top to see if there's anything I can cancel. All right. Well, help me factor the top, Max. Is there anything I can pull out?
No.
No. How many terms?
2.
Is it the difference of two squares?
Yes.
Is it?
No.
It's okay. Max on my face was like, yeah, no, it's not.
You're about like 8
All right.
seconds.
It's not. It's the sum of two squares. I can't factor it. It's done. There's nothing I can cancel out. This is the